Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. The course is Statistical Methods 1. This session is 8. In this session, we are going to deal with the new topic moments. So far, we have dealt with random variables, continuous, discrete, then corresponding probability functions, PDF, PMF, their cumulative distribution functions, CDF, and then mathematical expectation of a random variable, you finding mean and variance using mathematical expectation. All these topics have been dealt, and this is a new topic called moments, which is also related with the mathematical expectation. Okay. So, in this session we shall deal with the definition of moments. There are two types of moments, one is central, another one is raw. Relationship between the central and raw moments, some examples to find moments about origin and some arbitrary point A. So, the first definition goes with the definition of raw moments. The rth moment, always we will deal with the general term, rth moment of a random variable x is defined by expectation of x power r and is denoted by mu r dash. In this definition, nothing is mentioned about the random variable nature. It can be discrete or continuous, because the continuous and discrete random variable will differ only with the expectation. So, the rth moment of a random variable x is defined by expectation of x power r and is denoted by mu r dash is equal to expectation of r. So, this expectation of r is defined for continuous and discrete random variables separately. Mu r dash is equal to expectation of x power r. This expectation of x power r is defined as x power r into p of x if your random variable x is discrete. Okay. And this is equal to integral x power r into f of x dx. The limits is from total minus infinity to plus infinity if x is continuous, right. So, mu r dash is written as summation x power r into p of x, where x ranges for the limits if x is discrete, and integral x power r into f of x dx from minus infinity to infinity if x is continuous. So, in this definition we can find out mean and variance. What is mean and variance? We already know mean is equal to expectation of x. We know that mu r dash is expectation of x power r. Here the power is 1. So, when r is equal to 1, we get mean. So, mean is equal to mu 1 dash. What about variance? We know that variance of x is equal to expectation of x square minus expectation of x the whole square, and we already know expectation of x is written as mu 1 dash. What is expectation of x square? When you put r is equal to 2 in mu r dash, you get expectation of x square. So, this is equal to mu 2 dash minus mu 1 dash square. This is your variance of x. And discussing about moments about an arbitrary point A. The raw moment earlier discussed was moment about the origin. Now, this is raw moment, this is also raw moments. Raw moments about an arbitrary point A is the definition. Now, we are going to deal with the rth moment of a random variable x about an arbitrary point A is defined by expectation of x minus a whole power r. When this a happens to be 0, you get expectation of x power r, which is your raw moment earlier discussed. The first definition we have seen, that is mu r dash, expectation of x power r when a is equal to 0. When a is not 0, you get expectation of x minus a whole power r, and is this is also denoted by mu r dash, but for distinguish you can put A. Mu r dash is equal to expectation of x minus a whole power r. So, here also according to the definition you can have this as expectation of x minus a whole power r. This is equal to summation x minus a whole power r into p of x if x is discrete, and this is also equal to x minus a whole power r into f of x dx if x is continuous. The limits is from minus infinity to infinity, here x ranges. This is also mu r dash. This is moments about an arbitrary point A. What is the next definition? Next definition is central moments. So far we have dealt with raw moments, that is moment about an origin and moments about an arbitrary point A. When in particular when the arbitrary point is the mean, that moment is called as central moments. So, the definition goes with the rth moment of a random variable x about the mean is expectation of x, is defined by expectation of x minus e of x whole power r, and it is denoted by simply mu r. Mu r is equal to expectation of x minus e of x whole power r. This is written as mu r is equal to expectation of x minus e of x whole power r. This is equal to summation x minus e of x whole power r into p of x if x is discrete, and this is where here x ranges, and this is equal to minus infinity to infinity x minus e of x whole power r into f of x dx if x is continuous, right. So, we have dealt with the definition of central moments, definition of raw moments, and definition of moments about an arbitrary point. What is the relationship between these? Relationship between raw moments and central moment goes like mu 1 is always equal to 0, because this is representing expectation of x minus e of x whole power 1. This can be written as e of x minus e of x. This is always 0 irrespective of the nature of the random variable, whether it is discrete or continuous. Mu 1 is equal to 0 always. Okay. The proof is like that. And mu 2, the formula is mu 2 is second central moment, and the formula relating central moment and raw moment is mu 2 dash minus mu 1 dash square. Okay. Third central moment mu 3 is equal to mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 mu 1 dash cube. Mu 4, that is fourth central moment, is mu 4 dash minus 4 mu 3 dash mu 1 dash plus 6 mu 2 dash mu 1 dash square minus 3 mu 1 dash power 4. So, these are the 4 central moments. Usually we will deal with only 4 moments only. How to remember this formula? Mu 2 means mu 2 dash minus mu 1 dash square. Mu 1 dash square is written as mu 1 dash into mu 1 dash. When you add the suffix comes to be equal to 2. Similarly, for mu 3 dash it is mu 3, 2 plus 1 3, mu 1 dash whole cube written 3 times mu 1 dash into mu 1 dash into mu 1 dash, 1 plus 1 plus 1 gives you 3. Similarly, mu 4 dash is 4 here, 3 plus 1 is 4, 2 into mu 1 dash written 2 times, 2 plus 1 plus 1 gives you 4, mu 1 dash power 4 written 4 times 1 plus 1 plus 1 plus 1 equal to 4. These are the formula relating central moments with the raw moments. We shall go ahead with some illustrations finding the rth moment and then relationship between central moments and raw moments. So, the first illustration is find the rth moment about the origin, also find the mean and standard deviation of a random variable with PDF which is given by f of x is equal to 2 into 1 minus x for 0 less than x less than 1 and equal to 0 elsewhere. As already discussed in the previous sessions, mean and variance can be found out using various methods. Earlier in session 7 we have seen mean and variance of a random variable using mathematical expectation, and in this session also you are finding mean and standard deviation, but it is using the moments, okay, where a mean is a mu 1 dash. When you put r is equal to 1 in rth moment you get mean. Variance is mu 2 dash minus mu 1 dash square. From variance, square root of variance gives you standard deviation. So, first we shall find out the rth moment about the origin for this problem. What is f of x given to be equal to? F of x is 2 into 1 minus x for 0 less than x less than 1, right. What is the rth moment formula? Rth moment about origin, and the formula is mu r dash is equal to expectation of x power r. Since being a PDF, it is integral x power r into f of x dx from the limits minus infinity to infinity, where f of x is defined only in the interval 0 to 1, it is 0 elsewhere. Therefore, limits is from 0 to 1 x power r into 2 into 1 minus x dx. So, this is written in a simplified format so that it will be easy for us to integrate x power r dx minus integral 0 to 1 x power r plus 1 dx. Still I have not integrated, yet to integrate. So, this is equal to 2 into x power r integration is x power r plus 1 by r plus 1 minus x power r plus 1 integration is x power r plus 2 by r plus 2 within the limits x equal to 0 to x is equal to 1. Remember, we are only substituting for x, not for r. R is a general term of the moment. When I substitute the limits 2 into 1 by r plus 1 minus 1 by r plus 2. This is your mu r dash, that is rth moment about the origin, rth raw moment about the origin. We have to find out the mean. Mean is given by mu 1 dash, right. So, put r is equal to 1 in the equation 1. So, what happens when you put r is equal to 1 is equal to mu 1 dash, which is mean is 2 into, when you put r is equal to 1, 1 by 2 minus 1 by 3. When you simplify, it is 2 by 6, which is equal to 1 by 3. So, mean we have found out, which is equal to mu 1 dash, which is equal to 1 by 3. We shall see this after the break. Welcome after the break. Before the break, we have seen moments, definition of raw moments about origin, raw moments about an arbitrary point, central moments, relationship between central moments and raw moments, and we are doing a problem finding rth moment and then mean and standard deviation. We have so far found out the mean, you are yet to find out the standard deviation using rth moment about origin of a random variable whose PDF is given. Okay. So, we have to find out the standard deviation. The standard deviation goes as a SD, which is nothing but root of variance of x, and variance of x in terms of moments formula is mu 2 dash minus mu 1 dash square. Mu 1 dash you already found out and the answer came to be equal to 1 by 3. You are yet to find out mu 2 dash. So, where mu 2 dash is equal to, when you put r is equal to 2 in equation 1, you get mu 2 dash. So, 2 into put r is equal to 2 in equation 1. R is equal to in equation 1 you get 1 by 2 plus 1 minus 1 by 2 plus 2. 2 into 1 by 3 minus 1 by 4. Simplifying this, it is 2 by 12, 1 by 6. This is mu 2 dash. Okay. Variance of x is equal to mu 2 dash minus mu 1 dash square, right. 1 by 6 minus 1 by 3 whole square is equal to 1 by 6 minus 1 by 9. Simplifying this, you get variance is equal to 1 by 18. This is variance, but standard deviation is SD, it is root of variance. So, root of 1 by 18, which is root of 1 by 3 into root 2. It is 18 is written as 2 into 9, 9 root is 3 comes outside, 1 by 3 into root 2. So, we have found out mean answer is equal to 1 by 3 mu 1 dash and SD answer is equal to 1 by 3 into root 2, and rth moment also we have found out. So, this problem is over. We shall go to the next problem. Next problem is again finding rth moment about origin, mean and standard deviation of a random variable whose PMF is given. So, PMF is given means it means the random variable is discrete. So, we have to find out the rth moment again, mean and standard deviation. Okay. So, how to find out the mean and standard deviation for a random variable which is discrete whose PMF is given. X values are given to be equal to minus 2, minus 1, 0, 1 and 2. What is your mu r dash formula? Mu r dash is expectation of x power r. This is summation x power r into p of x. Your x ranges from minus 2 to 2, as from minus 2, minus 1, 0, 1, 2 and corresponding p of x values. It goes as minus 2 power r, the corresponding probability value is 1 by 8. For minus 1 power r, the corresponding probability value is 3 by 8 plus third x value is 0 power r into 1 by 4 plus fourth value is 1 power r into 1 by 8, fifth value is 2 power r into 1 by 8. This is your mu r dash equation, right. We can't simplify it further, you have to keep it as it is. This is mu r dash. From this we have to find out mean and standard deviation as discussed earlier. Okay. This I will mark this as equation 1. Okay. When you put r is equal to 1 in equation 1, we get mean. So, mu 1 dash is equal to minus 2 whole power 1 into 1 by 8 plus minus 1 whole power 1 into 3 by 8. The third term is 0 plus 1 power 1 into 1 by 8 plus 2 power 1 into 1 by 8. Simplifying it, this one gets cancelled, minus 3 plus 1 is minus 2 by 8. Minus 3 plus 1 is minus 2 by 8. So, mu 1 dash is equal to minus 1 by 4, which is nothing but mean. So, mean is equal to minus 1 by 4. We have got the answer, right. Next, you have to find out variance. Variance is mu 2 dash minus mu 1 dash square. Mu 1 dash you already found out 1 by 4, where you have to find out mu 2 dash. Mu 2 dash is obtained by putting r is equal to 2 in equation 1. So, it goes as minus 2 whole square into 1 by 8 plus minus 1 whole square into 3 by 8 plus third term is 0 plus 2 square into 1 by 8 plus 1 square into 1 by 8. So, this is equal to 4 by 8 plus 3 by 8 plus 4 by 8 plus 1 by 8. Okay. What is that equal to? 4 plus 3 plus 4 plus 1 by 8, which is equal to 12 by 8. You can simplify it, it is equal to 3 by 2. This is mu 2 dash. You are yet to find out variance. Variance is 3 by 2 minus 1 by 4 whole square is equal to 3 by 2 minus 1 by 16 equal to 23 by 16. This is variance. Your question is to find out standard deviation, not variance. So, standard deviation is equal to root of variance is equal to root of 23 by 16 is equal to root 23 by 4. So, for this problem we have found out again mean is equal to minus 1 by 4 and standard deviation is equal to root 23 by 4. This is the answer for the question discussed. So, next is if about the origin the first 3 moments are 3, 24 and 76, show that about the value 2 the first 3 moments are 1, 16 and minus 40. That is this problem is about finding the moments about an arbitrary point given the raw moments about origin. Okay. So, how to deal with this? What is given? Given raw moments about origin, that is expectation of x equal to 3, expectation of x square, these are all about origin, right. So, we can write directly expectation of x, x square etc. Expectation of x square is 24 and expectation of x cube is equal to 76. To find about an arbitrary point, so you have to find out expectation of x minus 2, expectation of x minus 2 whole square and expectation of x minus 2 whole cube. This is first moment about arbitrary point 2, this is second moment about arbitrary point 2, this is third moment about arbitrary point 2. We have to find out these 3 moments and show that their respective values are 1, 16 and minus 40. Okay. The first moment about arbitrary point 2 is mu 1 dash, this is also represented as mu 1 dash. E of x minus 2 is equal to E of x minus 2. E of x is given to be equal to 3, therefore, 3 minus 2 this is equal to 1. We have found out first moment. And the second moment is a mu 2 dash, which is expectation of x minus 2 whole square, expanding this expectation of x square minus 4 into expectation of x plus 4. Expectation of x square is 24 minus 4 into 3 plus 4. This comes to be equal to 16, right. And mu 3 dash is expectation of x minus 2 whole cube. This is expectation of x cube minus 6 into expectation of x square plus 12 into E of x minus 8. Substituting the respective values given in the question and which you have found out, 6 into 24 plus 12 into 3 minus 8, the answer comes to be equal to minus 40. So, we have proved the first moment about arbitrary point 2 is 1, second moment about arbitrary point is 16, third moment about arbitrary point 2 is minus 40. This is what you are requested to show in this problem. To do exercise, the first 3 moments about value 5 of a random variable is given and you are asked to find out the mean is 7, variance is 16 and mu 3 is minus 64. First you have to find out raw moments about origin and relate the relationship between central moments and raw moments and find out the mean, variance and mu3. In this session we have dealt with the raw moments, central moments, relationship between them. Some examples are also worked out depicting the relationship between raw moments and central moments. Thank you.